Just to reiterate some things that Matt and Jody said earlier, Grasshopper is technically a programming language. So you almost have to put your programmer hat on if you have a programmer hat. If you don't, you should pretend like you have one. And it's almost, if you have done coding before, you'll understand Grasshopper right off the bat, probably a little easier, because it's the way of thinking where everything is basically broken down into steps, like you guys kind of practiced or just did. The computers, while they are dumb, they're basically never wrong, except for maybe a bug here and there. But it does exactly what you're telling it. So if something's not working right, it's something in the process that's happened that is telling it to do what it's actually doing and not what you want it to be doing. Yeah. So you really have to break down your shape or break down your process to a real step-by-step thing. And it's not, like Matt and Jody said, it's not the shape you're kind of programming in, it's the steps to create that shape. And that process is explicit, so you have to tell it exactly what it needs to know. You can't, it can't draw something floppy like the hands on that thing. You have to tell it exactly step by step what's going to happen. So you need to know, instead of saying floppy, what is floppy what is actually making up something that looks like it's floppy. Right. And also, I think a place where people get stuck or caught up on Grasshopper is trying to figure out all the actual commands. So there are, there's the toolbar and with a bunch of commands on it. There's a million plugins with even more commands. So, the moment I open Grasshopper, I have like Google or the Grasshopper website open. Because obviously I've remembered a lot of commands, but it's not the commands that kind of make your project. It's the kind of step-by-step basis or the step-by-step process that you've kind of figured out before. And once you figure out what you need to do, it's easy to go, how do I, move a point in Grasshopper? Like, you need to move a point. It's easy to figure out how to do that in Grasshopper. And that's kind of similar with coding. If someone knows a certain coding language, it's really easy to move into another one. Sure, you have to kind of learn a new language, but it's the step-by-step process that's basically the same across, any coding language or Grasshopper. So that's the important part. You got to figure out how to build this thing, and then if you know what you need Grasshopper to do, it's super easy just to Google it or whatever and find how that's actually done. So, most of the times someone will ask me how to do something, and I've done it a million times before. I know it's possible, but the commands to actually do it, I have no idea. So I'll just bring up Google, figure it out, and that's basically how I work in Grasshopper. So the thing we're going to go over first is how Grasshopper stores and deals with data. This is kind of, you can start Grasshopper and never kind of figure this out, but you're going to run into issues, and then you're just going to start jamming different buttons, and sometimes it will work and sometimes it won't. But again, it's doing exactly what you're telling it to do, and it most likely comes down to how the data is being stored, and if you're using multiple kind of inputs, how that data is being matched to the other data that's also coming in. So if you have a list of points and you want lines to be drawn all between them, and then you connect to like lists of points and you got lines everywhere or no lines, it's because the data you're putting into those list of points aren't matching up or they're not working for some reason. So that's kind of how to deals with how Grasshopper stores data and kind of how it works with it. So that really is foundationally the most simple part of Grasshopper, but it's also, if you know how to do it, it will solve like 90% of your problems. And when I go through this, it might not make sense right away, but once you start actually doing it and start seeing how things start reacting when you're plugging components into each other, hopefully you'll be able to come back to this part and kind of realize what it's doing, what's going wrong, or kind of what's happening. Right. So the image here on the left is a visual representation of a Grasshopper data tree. Now this one is very complex. So I wanted to do this on the chalkboard, but can't really do it with the screen down, so I'm going to use paint. So if this being a super complex one, a super single one, or a super simple one, is simply just a tree with, and then the circle represents the piece of data. So on the left here, you have, you see on the right, you have, I don't know what that adds up to, but there's 100 they could be points. So 100 points of data, so 100 different points in Grasshopper, separated into what they call trees and branches and lists. So if you look here, there's 6 points at 0, 0, 0, 0. And that is basically, in this tree, 0, 0, 0. And here are those 6 points. And if you just have those, if the list was just this top one, it's just a list of 6 points, and it's kind of got a little code of 0, 0, 0, 0. Now, if I bring up Grasshopper here, you'll see this is just a point I've entered. So this is a point I drew in in Rhino and put into here. And this right here is saying there's 1 point, and it's just at 0. Right? So that is.
Sorry, how did you put it in?
Oh, that. If you have this point container, so it's just point. Right now it's empty. If you right-click on it and go set 1 point, it's either going to ask for you to click a point in Grasshopper here, or if you've got one already selected, it's going to just take that one.
I can cover some basic
Yeah.
stuff too.
So on this one, so when I go through this right now, I'm going to focus more just on these lists, and then when Brett goes over it, there'll be more of the commands. So don't worry about all the, I guess you can't see me cover my screen. Yeah. Ignore most of this stuff I've just kind of put in to create these kind of situations. So don't really worry about what I've done here.
Don't worry about how it got there, just what it's doing.
What it's doing,
in there.
if that makes sense. Okay. All right. So when you have multiple, I'm going to go back to points. So if you have multiple points together, it's a list, right? So it'll be point 1, point 2, point 3, point 4. That would be called a list, and that's what this is called. This is right here. So this little thing here has 6 points, right? 6 points in a list. If you when you start putting multiple lists together, that's when you start getting branches. So it all comes back to tree analogies. So this is a list of 6. This is a list of 9. This is a list of 9, and so on. So those are separate lists, kind of being passed on through Grasshopper together. Obviously, in this right here, this is just a list of 1. There's no branches, right? A list of 1, and this is a list of 1, again with no branches. And the little index you have up here just kind of shows you where in the tree it is. And obviously this one is just one list of 1, so it's not really a tree, it's just you have one little one all by itself. All right. So the important part, the part where it gets tricky is where you have lists of, or branches of data, so multiple lists together, and they need to interact. So here, I obviously have this point and this point going into the line command, which creates a line. This is working. You can see it's working because it's gray, and the line's been drawn in Rhino, because those lists are, the data within the list is at the same level. So they're both at 0 and at 0. So the part where things get mixed up is where, and you'll see later, is when things are not, when the trees and the location of the data are not matching, they won't interact, or they won't interact in the way you want them to. That is basically sums up 99% of the problems you'll run into in Grasshopper. Not that the command you're using is wrong. It's that you've got lists of data going in, you want them to do something, and they're not doing what you want it to do. All right. So here you see, again, simple. This top one is just a list by itself, and the bottom one is just by itself as well. So you have, this is the one point, and that's the other point, right? So you see that the data is the same, or it's in the same location in the tree. So when Grasshopper reads it, it goes, oh, this point and this point, those are the two sets of data that I'm looking at, and it will know that's then going to draw a line between those 2 points. So this next one here, I have, it's 3 points in one list. So I created this just by basically making 3 points in Rhino. I selected them all. I right-clicked in Grasshopper on here and go set multiple points. And you'll see now we still have, you know, we only have one branch, so it's 0, but there's 3 points in it. So if I drew that, it's one branch, and there's 3 points there. Does that somewhat make sense? All right.
Is the 0 like the hierarchy?
Yeah. So you'll notice on the complex one, the 0 is like the kind of code of where it is in the tree. This one obviously has a bunch of branches and all over the place. So it has this one. That one splits into 0, 0, 0, 1, 0, 2. Then 0, 2 goes into 0, 2, 0, 0, 2, 1. And then that one again goes into 0, 2, 1, 1, 0, 2, 1, 0. So if you wanted to, like this point is located in the list at this kind of hierarchy. So it all kind of starts at 0, it branches out again. Obviously this is super complex. Mostly you'll be working with things, you know, much simpler than this. So like basically 0 and then maybe 2 branches and your data is here. So on this next one,
When you explain things, can you use your mouse so that we'll
oh,
watch
sorry,
later?
sure. Right. So again, this right here has 3 points in the list. So it looks like basically this. Now there's a slight difference between how some components in Grasshopper read data. So this line command here obviously asks for 2 points. So you put 1 point in A, 1 point in B, and it draws a point in between. What this command here is interpolate curve, so basically it'll just draw a line through the points you give it. But what it's asking for is actually a list of points. So you see here, I've given it a list of 3 points, and in that order, 0 to 2, it draws the line through, starts here, through that point, and then to this point. And if we look at Rhino, you'll see that's what it's done. Started at the 1 point, gone to the next one, and the third. So what this one's asking for is a list of points to draw a line through. Now you'll see I've done almost the exact same right here, but if you notice the difference, it's got the same 3 points in it, but they're actually not the same list anymore. This is actually 3 separate lists, and you can kind of tell that by they each have a 0, 0, 0, 1, 0, 2, and they kind of have the dark separation between them. So if I drew this, it's not this anymore. Oh, it is that one right? So there's three branches of kind of three branches, and each one only has one item in each. So
Wouldn't they be connected to one? Like, would be coming from one? So they, instead of the first
right,
one-
sorry, so it kind of goes like that.
Yeah.
There you go. So you have this one, this is 0, if I can write. This is 0, 1, or sorry, 0, 0. That's 0, 1, and that's 0, 2. And you can see that if you look here, 0, 0, 0, 1, 0, 2. And the reason it's red, which means it's not working, is because it's asked for a list of points. I've given it a list of points, but each list only has one item. So it can't draw a line between one item, right? So if this list had more than 1 point, and this list had more than 1 point, and this list had more than 1 point, it would actually draw 3 separate lines, because it's looking at each of those lists separately, because they're located at on different branches of the tree. Does that make sense why that's not working? So we'll get to the why, how I created this separate than this one in a sec. But basically, I just grafted, which is another tree analogy, grafting a branch. So I took all those separate points and made them their own branch, right? So instead of a list of 3, it's now 3 branches. And because of the problem, or because of the reason, or due to the fact that you need data to line up within branches, a lot of stuff you'll be doing is manipulating the tree so things line up, and then when you connect things together, it does what you want them to do.
Can I ask something? So, whatever object we're using, does it have all the commands has to come from this tree? Like, if I have a tree and I'm trying to manipulate the object, whatever I'm doing, it's going to have to come from branches from the tree. It cannot have a different tree that connects to the
No, you'll see that if you have, so most of the time you're combining data. So if you combine, so if you had let's see. If I combined something like that looks like this one right here, right? It will end up, so that equals, it's going to turn out like this, right? If I because those,
So these are the tree with 2 branches, or just
no, it would be a tree with 1 branch, but there's 2 items in that list now.
okay?
So because they're in the same spot, when it combines them, it puts them in the same list.
Okay.
But,
They're not in the same.
right, so if you had one here, and then something like this, when you combine them, it's going to actually, I'm going to run out of space. This is located in here, so it's going to be like, there's going to be one here. So it's going to look like this, right? And if you wanted this to draw a line, you know, if you wanted this, if this is a point and these 2 are points, this thing you've now made has no lists of 2, right? So it can't. All the data is located in different spots, so it's not going to be combining them together like you want it to. And I think I have an example of that over here. So let me just hide those. Right. Okay, so similar to just that last example. Where is this? Okay. So again, don't worry about this at the moment, but what I've made is, if you can see this, so there's 121 points in there if you read that little box. There are 11 branches, and each one of those has 11 points in it. Can you see that? I can't move my mouse, sorry. Oh, actually, let me go like this. panels are your friends, and that's just this one here. So if you expanded this, 0, 0, 0 has a list of 11 points, and you have 11 branches going to 0, 0, 10 with 11 points. So if I put this into polyline, which is similar to the interpolate curve, is just going to draw a line between those the points in the list. I'm giving it 11 lists of 11 points, and because all those lists are at different, branches, it's going to treat them all separately. So here I've created 11 different lines through those kind of basically those branches, and it's treating them all separately. It's not joined. So that will act like that. But if so in this case, what I've done here is put them all into the same list. So now this is just one list of 121 points. And if I turn that on, you're going to see that it went down the first row, then went down, and then combined it with the second one. So now this is just only one line going through all 121 points. And the reason it's doing that is because they're all in the same list. Right? Before they were in separate lists, now they're all in the same. So again, I'm not going to draw all 110 points, 111 points, but it started out like, let's say there's 11 of those, with a bunch of lists like this. Right? So these ones drew one line. These ones drew, this is a good photo. This one drew another line. This one drew another one, and so on. And that other one was just like this, but with them all together. Right? And it used all of them together to draw the one line. And the way I switched between those was just, which I'll go over again, flatten. So what flatten does is just kind of flattens your tree out. So it takes all the branches and just kind of squishes them all together into one giant list. And you'll kind of, I have examples of them all, but all these kind of commands that edit the lists around like this, flatten, graft, simplify, shift, are like commands you'll most likely be using a lot throughout Grasshopper. So when you flatten it, it will take like 0, 0, 0. It will take that list, and then 0, 0, 0, 1. Like it does it in order. So if you flattened this tree right here, it would take the first item in this path. So it would take this list, and then the next ones would be this list, and so on. So it keeps that same. Well, it gets rid of all like the branches. The data is actually in the same order as it was before. So if I flatten this tree, there'd be the 100 or so items all just in one list, and the order would come from kind of this original structure it had. Right. Okay. Well, technically, it doesn't change any of the data within it. So, but what it will do is, a lot of times you're using the tree structure for your own benefit. So things are separate because they're different, or obviously, if I might not want usually I would want all these lines to be separate and not just or merge together into one giant line. If I flattened something prior to this, so all the data was now squished together, there's no way I could really get back to having it all separate, because I've taken that tree structure of the tree and kind of thrown it away. So at times flattening usually makes it a lot easier, because the tree's gone and everything just kind of goes together. But if I wanted to keep these separate, which I think would make sense, I've kind of gotten rid of that, and it will never come back, unfortunately. Okay.
Anyone else with tree structures?
Yes.
You could save it that way. Create a new
Yeah. A lot. You might, if you can take the same data, flatten it once, but then, you take the same data, save it twice, flatten one, do what you want to it, but you'd still have kind of the original prior. But so this is flattened right here. If we look, so here I have the interpolate curve again, and you'll see it's not working because these three are on different branches. Obviously, it's looking at this first list. It can't draw a line between just one point, so it's failing, and so on. What the flatten command does, like I just mentioned, is basically takes all the branches and just flattens it down. So if I look at what's going into flatten, again, it's kind of the same thing. But after, when flatten comes out, and it moved to 6 just because I had multiple points going in there, but it's now all in the same list. And when I put this into the curve, wherever that is, I have too many things drawn here, sorry. It's somewhere in here, but it's working. Yeah, trust me. How would I do this? There it is. So now that I've flattened all my data into one kind of list, it now works in something that's asking for kind of something in that needs multiple points per list. All right. So kind of the opposite of flatten is graft. So what graft is doing is, I'll draw this. Oops. So if I have a branch like this, and this one has 2, this one has 2, this one has 2. If I say graft to that, it's going to end up like right. So I've taken all the items in this kind of outer branch and made them all into their own branches. So obviously, if this was 0, this one's 0, 0, and this one's 0, 1, this one's 0, 2. This over here, you're going to have 0, 0, 0, 1, and this is now 0, 0, 0, 0, 0, 1. Right, and now those are just, it's not a list of 2, it's just a list. It's a new branch, but it's only got one per branch. So it's kind of done the opposite of what flatten did. And the reason why you would want to do that, okay, let's look at this example. Okay. So I'm just using the line command here. So what the line command is going to ask for is obviously a point A and a point B. Up here, I have these 2 points. So a point here and a point here. So I'm giving it 2 points in the A. And if I go down here, let me just get rid of those. I'm giving it basically a list of 11 branches of 11 branches of a list of 11. So there's 121 points there. So what it's doing here, sorry, one sec. It's taking the first point that I give it, so this point here, and it's drawing it to the first point in those lists of 11. So let me just draw this. So this first one is just this. Oh no, it's not like that. It's this. And this next one is there's 11 in here. So basically it's taking these two and then these first 11. And the way Grasshopper kind of deals with this, if you give it two lists of things like this, it will take, so let's just draw this separately. Right, so here's my first list of 2, and here's my list of 11, or however many that is. Now I'm telling it to draw lines between all these points. It's going to look at this point and go, okay, I'm going to draw this to the first one, like this. And it's going to look at the second point, draw it here, and then it goes, well, the lists don't really match up, so I'm just going to draw this to there, this to there, this to there. Right? Because the lengths don't match up. You have 2 matching to 11, but that's, Grasshopper goes, well, I'm just going to do this. And that's, if you look at what's happening here, you see this first point is drawing to this first point, and then the second point here is drawing to the next in the list. So that's how it's calculating that. Now if we wanted this point to draw to all of them, and this point to draw to all of them, what we're going to want to do is create, just let me, right. Something where it's more like you have 2 points, just drawing to the 1, a list of 1. So then this will draw here, and that will draw there. Right? That's kind of in our head, that's what we want to happen. So instead of this list of 11 points together, we want to separate those so each of these are its own list. And that's where graft comes in. So you see I've added the graft command right here, and instead of 11 lists of 11, we now have 121 lists of 1. And you can see, if you can see that on the board, the n equals 1, and let me get rid of that. You can see down below, or even here, that each point is in its own list. So now if we look at how that's working, each of those points is drawing to every point kind of in the other one. So those like grafting and flattening, you know, if you wanted this, but you were seeing this, you would kind of know that obviously these lists aren't really kind of matching up and doing what I wanted to do. So it's usually graft or flatten that kind of solve those issues. Kind of the other kind of command here is simplify. So all simplify is doing in a graphical paint view is if you have something like this, it basically gets rid of all the branches you don't technically need, and it will turn it into, there's 6. It'll basically turn it into that. So if we look here, kind of the original list has 0, 0, 0, 0, 0, 1, 0, 0, 2. So it kind of looks like it's got the 0, which branches again. If we simplify that, you see we just have now 0, 1, 2, 3. So it's kept the actual list separate. It's just kind of gotten rid of all the branches that aren't really needed. But the problem with that, like I mentioned before, if you want to combine two trees together and the data to line up, they need to be similar. So if I had another one that looks like this, so let's just say it's this one and this one, and if I now tried to add them together, it would look like something like right, because this is all zeros. This is the 0 branch, so this one actually gets put over here. Right, so they're not going to add together like technically you wanted them to. Does that make sense? Okay. And you'll see here, I'll see. Now this is different than this. When I add them together, it creates this. Right? So it didn't combine. So you got 0, 0, 0, 0, 0, 0, 1. And you'll see that is much different than up here, where it took like 2 lists of 3 and added them together because they're at the same spot in the tree. Right. So if you added two of these together, you would get something that was nice, where you had those lists would combine. Right. But because if I simplified this and then tried to add them back together, you get the weird thing, because now those branches all don't kind of line up, and you get this weird. Probably not what you want. Okay. Just 2 more. Flip matrix. So this one's hard to explain other than a nice little drawing. Again. So if I have, this might take Word. Explaining Grasshopper in Word. All right, so if I have a list of numbers, it's trouble. All right, so pretend this is branch 0, this is branch 1, this is branch 2, and so on to branch 8. Right, and each one has, these could be points, but for easy sake, they're just numbers. If I flip this, what's going to happen is 0 is going to turn into 1, 1, 1, 1, 1, 1, 1, 1, however many is right. Yeah. They're supposed to be however many I have in here. Okay. Right? So it's almost like it looked at this as a grid, and when you flip it, it's going to take the first ones of all of them, put that into a list, the second ones of all of them, putting that into a list, the third one, so on, all the way to the end. So it's kind of if you're looking at them in grids, it just flips it, and you're now looking at them in columns, kind of. And for more of a graphical sense of what that looks like, right? So it has. So what I have here is basically a list of points. I have a bunch of lists, and it's making, similar to before, like a line through each kind of each list. If I flip that, it's going to take the first point of each of those lists and put those into a list, the second point of all of the lists and put those into a list. So basically, what that's going to look like if you draw the lines through them, is basically just kind of put them in the opposite direction. Because now they were all going the one way, but now it's kind of flipped the points and kind of reordered all the lists, if that makes any sense. So before the lists were like this, these 6 numbers were in a list together, these 6, but then it took the first of all the lists and put that into a list, and then made that into a list. And when you use the polyline, it's looking at that list to kind of create the list of points to create that line. And finally, there are a few more kind of commands that edit branches and trees, but these were the ones that I think I've actually used. The other ones get pretty complicated, and you might never even come across any situation where you need to do them. But this last one here is shift. So this is almost like flatten. So where flatten basically takes the whole thing and flattens it all down together to like kind of the base. This one is a little more selective. So you can get good at this. So where flatten would basically put all these together like this, shift list is just going to shift it down one level. So if I shifted this 1, it would turn into like that. And obviously if I shift it 2, it's then going to look like this. Does that make sense what kind of shift does? It's just kind of shifting it down. And you can see that here. Sorry, this is shift. Right now I have it on 0, so it's just the actual what it was before. 0, 0, 0, 0, 0, 1, and each one contains 8 numbers. If I shift it -1, now each one, sorry, this was set up slightly different than the drawing, but now you have 0, 0, and it contains kind of all those numbers. If I shift it 2, it now is just at branch 0. So it's basically just shifting it all down 1, and in that process, it kind of combines some of the data as well. Well, once it's done, I could. Well, technically, no, you can't. Right, and you can, but you have to tell it so you can graft, and then everything would become its own branch. But it doesn't really remember, if they were branches of like 4, and then you combine it down into 16, and then you try to go the other way, like it doesn't remember that it was branches of 4 before. It would just, you would have to tell it, go back to 4, or go back to kind of something else. So it doesn't. You might come across that a few times where you kind of have to flatten something, and then you need it to match up with something you hadn't flattened previously. In that case, that's when things start to get slightly complicated. But usually, just try not to like get rid of everything, and like try not to flatten if you don't really actually have to, because it does kind of it won't remember for that stream of data like what it used to be. So things will start not to match up anymore. Yeah. Yeah, I mean, it kind of depends what you want. So sometimes you want to keep things separate. Sometimes you want to flatten. But yeah, I mean, usually at the end, closer to the end of the script is when you can start flattening stuff a little more, because you usually don't need to remember all like the structure you had before. And some things, like if you just want to count how many items you have, if you give it 11 lists of 11 and you ask it to count the numbers, it's going to give you 11 counts of 11, right? Because it's looking at each thing separately. If you just want to see how many total, you just flatten it, put it into count, and it'll give you like 121. But you could, for that point, for that, you might just have that flattened there, and then elsewhere in your script, you haven't flattened it, right? So it will continue on with its thing. You just, for that local kind of problem of counting all your values, you needed to flatten it there, right? So it can, just depending on kind of what you're doing with the data, it might need to be flattened or kind of grafted. Right, so that may have made no sense whatsoever, or it may have been crystal clear, but when you start actually playing around with it and things start not to match up, the reason is because your data trees are different, right? So you'll find that these editing ones, flatten, graft, simplify, flip, and shift, will be used a lot, like just prior to either creating something, because you need those lists to start lining up. So now when you actually see a script that's going to create something, I'm sure it will make a little more sense. And hopefully it's easy to, sorry. My script is beautiful. See this? When he brings his up, you're going to see what not to do. So when you when you annotate, and sorry, but a little. All right.
I've got no comebacks.
Yeah, that's it. But you'll find that kind of annotating and keeping it neat part usually happens after, because when you're creating it, I'm sure you've probably already figured this out, things go everywhere and it's crazy. But especially when you start to build up scripts, there's times where I know I've done something before, and then I'll go back into a script from even like a month ago, and I'll have absolutely no idea what the script is doing, because it's hard to just like take a look at it and glance at it. So even when they're kind of neat, it's hard. It's hard to kind of take something from an older one. So the more kind of annotation and logic you put into how it looks, the easier it is to go back and kind of not have to redo things you've already done. So hopefully this one, and when I open this in a month, it will make some sense. Or when you open it, it makes some sense. But yeah, the keeping neat part is relatively important.
So you talked about the annotation. Can you actually do it by saying that?
I'll go
Yeah.
over that.
Yeah.
Yeah.
So I mean, there's tons of ways to make it look. You can put it groups like this, titles, or even just take these panels, right? And it's just, you can write whatever you want in here. So like, this is doing this, this is doing this. So that's kind of the good practice there. But I will sign off here, and then Brett will take over.